Hi, my name is Matthew Bascom, and this is Graph Factor. This is my XORPD series where I walk you through explanations of XORPD's famous opcode book, Exchange RAX. Let's get started. XORPD Challenge Hex 3 tests to find the minimum value between RDX and RAX. The RCX register is not initialized, as its purpose here is to check if the subtract operation, sub RDX RAX, resulted in setting the carry flag. Recall that the carry flag is set if the subtract operation results in a negative value. If sub RDX RAX resulted in a negative value, then the subtract with borrow operation would perform RCX minus the carry flag and store -1 in RCX. Otherwise, if the subtract operation sub RDX RAX was positive, then RDX is greater than RAX and the carry flag is not set. As a result, the subtract with borrow operation would cause RCX to be 0. The AND operation, AND RCX RDX, performs a bitwise AND. RCX is either 0 or -1 after the subtract with borrow. So the bitwise AND will leave RCX as 0 if RCX is 0, assuming RDX was greater than RAX, or it will set RCX to RDX if the subtract operation set the carry flag and caused RCX to be -1 during the subtract with borrow operation. Since -1 in binary is expressed by every bit in the register being 1, that is, if RDX was less than RAX, then RCX serves as a bit mask, with the AND operation causing the set bits from RDX to be the only set bits in RCX. Here the XORPD Challenge Hex 3 is shown on lines 24 through 27. RDX is initialized to 3 and RAX is initialized to 5 on lines 18 and 19. And I'll show a different case for when RDX is also greater than RAX after we walk through the first example. So let's compile this. And link it. And just as usual, we see that it runs pretty quickly. It's a short program, so we're going to open it up with GDB. And I'm going to start by setting a couple parameters in the debugger so that we can see the lines as they're executed, or rather just before they're executed in the debugger, and compare them to the script, the assembly file. And I'll set the assembly flavor to Intel and set a breakpoint at main. I'm going to run. And the registers we'll be interested in during this exercise will be RAX, RCX, RCX, RDX, and the E flags. And we see that the registers initially just have RAX, RCX, and RDX have junk data, and we see the next operation that's going to be performed is a move of 3 into EDX. Now again, EDX is 32-bit architecture convention, but it's actually going to be placed in RDX. So we're going to step through that a couple just for the initialization steps. And so now we have the number 3 in RDX, we have number 5 in RAX. RCX still has junk data, and we're about to perform the first operation of challenge hex 3, the subtractor, subtracting our AX from our DX. So one thing we're looking for here is whether the carry flag is set. So far, the carry flag is not set. We see that the parity flag is set and the 0 flag is set. Now, if RDX is greater than RAX, the carry flag will not be set. But if the result is negative, if RAX is greater than RDX, then the carry flag will be set. And what we'll see is that in the next operation, after performing the subtraction, that we'll see CF down here, so that it will set the carry flag. And here we see carry flag is set. The subtraction placed, the result of the subtraction was placed into RDX. So we see we've got -2 here in both base 16 on the left and base 10 on the right. And the next thing that we'll look for is the subtract with borrow. Now, since the subtract with borrow shows RCX, it essentially subtracts the RCX minus RCX will be a 0, but it also subtracts the value of the carry flag. And since the carry flag will be set, it'll be RCX minus 1, and the result will be placed in RCX. And we'll see that this junk data here becomes -1. And so now we have the carry flag set and -1, like we were expecting, placed into our RCX. Now that RCX is populated with -1, again, because the operation of the subtract set the carry flag, and the subtract with borrow set RCX to -1. We're now going to use that value in the AND operation on line 26. So the AND operation of our RCX with RDX is going to basically take every bit that's set in both registers and assign the result to RCX. So what we'll see next is this -2 being copied essentially from RDX into RCX. Finally, we'll be doing the add operation of RAX with RCX. Since RCX is -2 and RAX is 5, the result will be 3. The result will be assigned changing RAX from 5 to 3, and that is the last assignment of challenge hex 3. So by contrast, if the original subtraction of the challenge sub RDX RAX resulted in no carry flag, then RAX would be unchanged throughout the progression of the program. The bottom line being that this challenge returns the smaller of the initial values of RDX and RAX. In this case, with add RAX RCX, since RDX since the original RDX was 3, the value of 3 will be assigned to RAX. And that's what we'll see in the next instruction. We'll show the registers, and there we have 3. Next, what we'll do is a quick illustration showing what happens if RDX is greater than RAX. So I'm going to go over and I'm going to comment out RDX, the assignment of 3 to RDX, and uncomment the assignment of 7 to RDX. And we're going to remove the original executable and object files and recompile it. Set our parameters for the debugger. And set our breakpoint at main. Again, looking at focusing on RAX, RCX, and RDX, as well as the E flags. So far we've assigned 5 to EAX, we've assigned 7 to EDX, and we're going to perform the subtract instruction. Let's take a look at our registers. And we see that RDX is 7, RAX is 5, and the subtract operation, since RDX is greater than RAX this time, will cause just the number 2 to be placed into RDX, and the carry flag will not be set. And there we have that. So the next we have the subtract with borrow, which will assign a value to this RCX register. Since it's just subtracting RCX minus the value of the carry flag, in this case it'll assign 0 because the carry flag is not set. And there we see that the 0 flag is set because the last operation resulted in a 0. The parity flag is set because there is an even number of bits being assigned to RCX, or, well, in this case, technically speaking, since 0 is divisible by 2 and has a remainder of 0, then that means that the parity flag is set. There's for the sake of the assembly, it's an even number of bits in RCX. The next, we have the add operation. So that's the AND operation. Okay, no, we have the AND operation. RCX with RDX will be 0 since the AND with 0 will just result in a 0, and RCX will remain unchanged. So we see RCX is unchanged, and then we add RAX to RCX, and that just leaves 5 alone. And that's the last instruction of the challenge. Just confirming that RAX, the last assignment, RAX, simply returns the lesser of the 2 values initially set in RDX and RAX. And there we have it. RAX is still 5 left unchanged. Just note on bookkeeping. At the end of the program, on lines 34 through 36, the value of the RAX register is set to 1 just before calling hex 80, which is the interrupt instruction used in this case to transfer control from the program back to the Linux kernel. The value of the RAX register is used as the system call number when the interrupt hex 80 instruction is executed. In Linux systems, the value of 1 in the RAX register corresponds to the exit system call, which terminates the program and returns the value in the RBX register as the exit status. The XOR RBX sets the RBX to 0, and as an exit status, 0 indicates the program has executed successfully. In summary, the objective of XORPD Challenge Hex 3 is to identify the smaller initial value between the RDX and RAX registers. That's all for this challenge. If you've watched this far, please comment, like, and subscribe. Thank you, and see you next time.